Hello guys, welcome back to my channel. My name is Ankit and in today's video, this is the day 3 of our complete Linux course, and today we are going to deep dive into users and group management into Linux operating system. If you missed to watch our previous sessions, so please make sure that you check it out, and we have provided a links in the description. By the end of today's video, you will have the skills to create and manage users and groups and assign permissions on users. So let's jump right in. So the first topic is understanding the basics. So in Linux, users and groups control access to resources. There are different types of users available in Linux operating system. So what all types of users available in Linux operating system? First one is root user. So we have root user in Linux operating system, which is the admin user, and the root user is the system administrator with so root user is the system administrator with full privileges, and root user can do anything on any so root user can do anything on any particular Linux operating system. Second one is system users. So whenever we install any applications like Apache, MySQL, so those specific services create users like Apache, MySQL. So these are system users which are specific to certain services. Third one, we have regular users. So first one is root user, which is a full privileged user. Second, we have system users. So system users are app users, application users like MySQL, Apache, MongoDB, etc. Third, we have regular users, and these are the users we use on a day-to-day basis to perform various tasks. Then we have guest users. So guest users are nothing like these are the users who get temporary access to the servers. So so this could be, for example, this could be project managers or team leads, etc. Then we have locked users. So these are typical users who can't log into the system, and they exist for system purposes, and they exist for system purposes. So we have like root user, system user, regular users, guest user, and locked users. So these are the major 5 types of users that are available in Linux operating system. The second chapter of this particular session is user management commands. So we are going to cover user creation, user deletion, and user modification commands. So let's start with user creation command, and we use user add command to create user. Then to modify user, the command is user mod. So to modify user, and to delete user, we have user del command to delete user. So let's add one user. So we'll create user named John Cena, and the command would be user add -m -s bin bash followed by name of user. So John underscore Cena. So this command has created a user named John Cena, and here flags -m and -s are used to create this user. So -m is used to create home directory for this particular user, and -s is used to provide the shell for this particular user. So if I want to check whether the user has been created or not, I can check using id command, and here you can see John Cena is created with user id 1006, the group id as 1008, and this is the group that has been created. This is the default group that has been created for John Cena user. Next thing is to assign password. So to assign password to the user, passwd is command to assign password to user. passwd followed by John Cena. This will ask for a password for this user, that is John Cena. So we'll give password as root, etc. Okay, so password has been assigned to John Cena user, and this is pretty much about user creation. Next thing is modifying user. So uh, let's suppose John is moving a department, and previously he was working for operations team, and he wants to currently so previously John was working for operations team, and now let's suppose he want to work for development team. So his directory needs to be changed in this particular case. So the command to change his home directory would be something like this: user mod followed by -d, and we have to specify the new home directory for John Cena user. So let's suppose John will move to this direct John. So let's suppose John will move to this particular directory once he change his department from ops to dev, and we need to specify the user. So this will modify. So here -d. So here -d flag is used to provide the changed home directory for this particular user. And if I so whenever we create any user, the entry is created in etc passwd file, and if we tell the file, it will show the last 10 entries for this particular file. So let's see. So here you can see the default home directory has been changed for John Cena user. So once user is modified, existing home directory gets moved to new home directory. So existing home directory is moved to this particular new home directory. So this is all about user modification. Next thing is user deletion. So if you want to delete this user, the command would be user delete -r followed by username. So John Cena. So this will delete the user along with user home directory and mail spool for the John Cena user. So let's delete the user, and mail spool is not present for this user, and it has deleted the home directory for this particular user. So if you get the passwd file, the John Cena user is deleted, and you don't anymore see the John Cena user present on this particular VM. So we are pretty much done with the second chapter, that is user management, and we have covered user creation, user deletion, and user modification command. Next chapter is group management, and we are going to cover group creation, group deletion, adding user to the group, and we are going to see primary and secondary groups. So let's create a group called developers, and we'll create a dev group for developers. So the command to create new group is group add command followed by to create new group. Group del is the command. Group del is the command to delete the group. So let's add a developers group. So group add followed by name of group dev. So group dev already exists. Let me create developers group, and here we have created developers group. If I want to check whether the group has been created or not, the file would be this group followed by del. So here you can see developers group is created with group ID 1008. And now let me recreate the user John Cena. So user add -m -s bin bash John Cena, and John Cena was a part of ops team. Now he has changed his department, and he will be part of developers group. So in order to add John Cena into developers group, we have to use user mod command. And if I currently see what all groups are present for John Cena, so we can see that using id command. So John Cena is currently a part of John Cena group only, that is default group for John Cena. If I have to change it to if I have to add John Cena to developers group, the command would be user mod followed by -ag followed by name of group, that is developers, and the name of user, that is John Cena. Let's check whether the user has been added or not. And here you can see John Cena is now added to developers group. So we are done with group creation and adding the user to the group. Let's see what is the difference between primary and secondary group. So whenever we create a user created with default group. So in John Cena's case, the John Cena user gets created with default group, that is John Cena. So this is the primary group for John Cena, and the developers group is the secondary group for John Cena. User can only have a one primary and he can have multiple secondary groups. So let's change the primary group for John Cena to developers. So the command would be usermod -g followed by name of group, so developers, followed by name of user John Cena. And if I type now John Cena, here you can see the default group for the John Cena have been changed. The primary group have been changed for John Cena user. So this is all about primary and secondary group. And user can have multiple secondary groups. He can be part of multiple secondary groups, but he can only have a single primary group. So the last thing is group deletion, and in order to delete the group, the command is group del followed by name of group, that is developers. Here we are not going to delete the group as we would need it for the rest of this chapters. So we will keep the group as is, and we will need this particular developers group for the rest of the chapters. So far we have covered third chapter of this particular session. Let's move on to next chapter of this particular session, that is file permissions and ownership. And the first point of this particular chapter is ownership. So let's understand ownership with the practical example. So let me quickly create project.cfg file using touch command. And if I get the details for project.cfg file, here I can see some details have been given by ls-l command. So ls-l stands for long listing of files. So the details are represented for this particular file, and we are going to see what all details actually represent. So let's start with the first section of this particular output, that is this one. So this particular section represents permissions, type of file and permissions basically. So type of file plus permissions on file. So this first section represents that this particular file is which type of file. So hyphen is nothing but a normal file. If this starts with D, that means this is directory file. If this starts with B, that is block file. So hyphen is nothing but a regular file. If this output starts with D, then this is directory. If it starts with B, that is block file. And there are various types of files that are available in the Linux operating system. So these are the commonly used files, and you can see it and you can identify it using the ls-l output. And the first place is represented, the first place is given for type of file, and the rest of the bits represents the permissions. So ownership in ownership there are three things. It starts with owner. Owner is someone who created the file. So owner is someone who created the file. Owner is someone who created the file. So first thing is first type of file. Second thing is permissions. So these are the permissions. And in permissions and ownership, we have three categories. So in ownership, we have owner. So owner is someone who created the file. So here you can see root is the user, root is the owner who has created the file. Then second one is group. So group basically represents users sharing the group permissions. So basically represents what what all members in the group has access on this particular file. And last one is others. So others basically represents all other users. So these are the three major uh, these are the three type of users under ownership that will get access to any file in Linux operating system. So here the permissions are 644. So the permissions assigned to this file are 644, which simply means that user has read write access. So user has read write, group has read, and others also has read. Group and other users have read access basically. So the first section we have covered. The next thing is this one. So this one represents number of hard links created for file. So we have two types of uh, symbolic links in Linux operating system. So there are symbolic links, two types of symbolic links. First one is soft link and second one is hard link. Soft link is a copy of file, or a soft link is a shortcut of file. So in Windows we create shortcuts for any file on desktop, or we may create a different shortcuts for easy accessibility of any particular file. So similar way in Linux we have soft links to create shortcuts for file, and we also have hard links. So hard links are basically a copy of file, exact copy of file. And hard links basically have same inode number. So this is the hard copy, exact copy of file, and hard links basically have same inode number. So the number of hard links is represented by the second section. So second section, number of hard links. Okay. So we have covered first section and second section. Third and fourth section. Third section is owner who created the file. Third section is owner who created the file, that is root. Fourth section is group who has access to this file. So in this case, a default your group, that is root group, has access to this particular file. Then fifth section basically represents the size of file. Fifth section represents the size of file. So in this case, this is 0 KB file. So this is 0 KB file. Sixth section represents this sixth section basically represents the last modified date and time. So last modified date time is represented by the sixth section, this one, and the last one, seventh section represents file name. So these are the 7 sections that are being used to represent the file details. So similar way you can check for any file. So basically you can interpret this output in this format. So you will understand who has created the file, when it was last modified, what is the group of this file, what all permissions are have been given here, what is the type of file, what is the name of file. So all those things you can interpret by yourself. So this is what is the size of this file. If you type ls-lh, you will get the size. Currently we don't have any information in this file, that is the reason it is giving 0. If we type some data into these files, it will show the size for this particular files. So this is about understanding ownership, and the next thing is changing the ownership. So let's change the ownership of file, and we'll assign project configuration. We'll assign ownership. So let's check. So let's try to change the ownership of project.configuration file to John Cena. In order to assign ownership, so chown is the command, and we need to provide the username, that is John Cena, and the group will be developers, and the file name is project.cfg. So invalid user. Okay, so let's check whether the user is present or not. John Cena is not present. Let me create user quickly. John Cena. A group John Cena exists. If you want to add this user to that group, so we need to provide the group name as well as this group we have already created earlier. So if I now check whether the John Cena user is created or not, so user is created, and let's quickly assign ownership to the let's change the ownership of project.configuration file to John Cena and developers group. If I now check the details for project.configuration file, so it has been changed. Earlier it was root, now it has been changed to John Cena and developers. So this is pretty much about changing the ownership of any file. Similar way you can change the ownership of any file or directory. Next thing is modifying permissions. So in order to restrict access to files and directories, we use or we modify permissions. So in order to restrict access to project.cfg file, we have to assign permissions, we have to modify permissions. So only owner can read write file, and group can only read, and author should not have any access. So let's assign permissions. Let's assign permissions to project.cfg, where owner should have full access, group should have read only, and others should not have access to it. So to do that, we need to check the current configuration. So current configuration is 644. That means user has read write access, and group and authors has read access. So to change the permissions for this file, we'll assign 7. That means John Cena user will have full permissions. Then read permission for developers, that is group, and 0 for others. And just provide the file name. If I now check the current configuration, so here only John Cena and developers have access on this file project.cfg. Others have no access on this particular file. So this is pretty much about file permissions and ownership. Next chapter is advanced permissions, and we are going to cover ACLs. ACLs stand for access control list, and if you want to assign permissions to specific users or group without affecting others, you can effectively use ACLs. Let's give a John Cena write access to a file owned by background. So let me create a file named background.cfg, and okay, sorry. So in order to create file background.cfg, the command would be touch, and in order to assign ownership to vagrant user, the command would be chon vagrant vagrant vagrant.cfg. If I check the details, file details for vagrant.cfg, it can show. Here we can see the vagrant user has only access to vagrant.cfg. Now, if the requirement is to assign one more user a full access on this particular file, so how you can achieve that? So let's suppose now the requirement is assign John Cena full access on vagrant.cfg. So in this particular case, this is the special requirement, and this can be fulfilled with ACLs. So the command to assign ACL is set FACL. To assign ACLs, to check the ACLs, the command is get FACL to check ACLs. So let me assign ACLs quickly. Set FACL, modify username is John Cena, and I want to give read write X full access on vagrant.cfg. Get FACL followed by name of file, and here you can see this vagrant file as the owner vagrant, and vagrant user has read write access, wherein user John Cena has full access on this particular vagrant.cfg file. Let me quickly check if that is true or not. So let me switch to John Cena user, and let me quickly. Okay, so this file is created inside root, so user won't be able to access root file system. So let me move this file to /tmp directory, and let me switch to John Cena user again, and let me go to tmp directory, and here I can see vagrant configuration file is there present, and here you can see the plus sign denotes that ACLs are assigned on this particular file. Get FACL followed by vagrant.cfg, and here you can see John Cena still have access on this particular file. Let me quickly add some content to this file, and let me save this file. If I simply check what all the things I have written to this file, I can check. That means I have read access. That means I have write access, read access. If I want to delete this file, let's see. So rm is the command to delete the file, and so here you are not permitted to delete this file, and the reason is vagrant is the user, and that is the reason you are unable to delete this file. And there is one more permission, special permissions, that we are going to see, because of which you are unable to delete this file, and that is sticky bit. /tmp is the directory which has sticky bit right here, and no other users can delete the file which is created by the owner. So only owner can delete this particular file. So if I switch to vagrant user, and if I switch to tmp directory, here we can see vagrant file is there, and if I try to delete this file, it will get deleted this time, because this file is created by vagrant user, and /tmp has sticky bit, and the concept of sticky bit says that a user can delete file in a shared drive, and user is nothing but a owner of this particular file, only can delete the file. No other user can delete this file. So here you can see the file has been deleted now. So this is the concept of sticky bit. So the next concept of advanced permissions is SUID, SJID, and sticky bit. So let's see what is SUID. Set user ID. SJID stands for set group ID, and the next one is sticky bit. No other user delete. Only owner can delete file. Only owner file owner can delete file from shared directory to avoid accidental deletion. So to avoid accidental deletion, only file owner can delete this type of files which are present inside sticky bit directories. And SUID is used to execute program with the file owner. So if you assign SUID on XYZ file, so let's create one file here. Let's create one file John Cena. Okay, if we change the permissions for John Cena to John Cena user, in advanced permissions, in advanced in advanced permissions, we have covered ACLs for now. So far we have covered ACLs. Next thing is special permissions. So in special permissions we have SUID. SUID stands for set UID, user ID. So SUID is used when you want to execute program with file owner. In that case you can assign SUID, and the command to assign SUID is chmod q plus s followed by file name. So this way you can assign SUID on any file. Next thing is SGID to set group ID. So SGID is used basically to, so whenever you create files which has SGID, the files will inherit group ownership. So file will inherit group ownership, and the command to assign SGID is g plus s followed by file name. So you can assign SGID on directory as well. So this is all about SUID and SGID. Next one is sticky bit. So sticky bit is used to prevent accidental deletion of files, and only owner can delete file. So in previous example we have seen that when sticky bit is there, even RWX user cannot, even a user with full permission cannot delete the file. So this is all about advanced permissions. Next thing is managing default user environment. So we in Linux we have etc scale directory, and if you want to see hidden files in Linux operating system, you need to use -la flag, or -a flag is used to see the hidden files inside any directory. So ls-la followed by etc and scale directory. So this scale directory is copied whenever a new user is created into a Linux operating system. And scale stands for skeleton. So this is the skeleton, and that is being copied to every new user's home directory. So when you create a new user, their home directory is initialized with the files from etc scale. Let's try to see the practical example of etc scale. So let's see the practical example of etc scale, and the requirement is we have DevOps group, and they have they have their tools and commands present in USR local DevOps tools path, and they want DevOps group member to have access to these tools by default. So how you can achieve this thing? So let me first create a DevOps group. and let me add some users to this group. So user add -m uh -g DevOps, and the name of user is dev1, dev2, dev3. So we have created 3 users, dev1, 2, 3, and we have added those users to DevOps. Here you can see they are the part of DevOps. Next thing is to create some commands inside this particular path. So we'll create a DevOps tools directory. Oh, this should be user. Okay. Okay, so we have created a directory user local DevOps tools, and here we need to create some commands or tools which would be accessible to this developers. So let me quickly add some commands. Dev project, uh, echo. Let's initialize the DevOps project. QA testing. Let's initiate the QA testing for Dev project. So these are the two scripts that we have created, and we'll assign full permissions on these scripts, and we have assigned full execute permissions on these scripts. Next thing in the requirement, let me recall the requirement here. So we have created DevOps group, we have created tools for DevOps group, and we have created a path as well, and we have also created group as well as members. Now we need to make sure that the new group members should have access to these tools. So let me make changes to etc scale directory. So etc scale followed by .bash rc. So .bash rc is the file where you can add function aliases paths which will be default to the users when they get created. So let me change the bash rc file, and here we have the host tool. So we already have this path. We'll just update the path here. So this way you can add the path. So export path followed by $path. We already had this dev tools. We have added this new DevOps tools. We'll save the file now, and let me switch now ID dev1. So let me switch to one of user and try to first check what all tools we have created. So USR local DevOps tools. So dev project and QA testing, these are the two commands that are available. So let me switch to dev1 and let me type dev testing. So this is not available because we already have created these users. So let me delete these users, user del, and recreate these users. -r dev1, dev2, dev3, dev1, dev2, dev3. We have deleted the users. Next thing is to re-add these users. So dev3, dev2, dev1, and this is done. Now switch to dev user, dev1 user, and try to access those commands which we have created in DevOps tools directory. So the command was QA testing, and here I can able to access the QA testing command, then dev project command. So let's initialize the DevOps project. So I can able to access the commands which we have created inside DevOps tools. So this is all about etc scale directory, and with this approach we can manage the default user environments. The next chapter is monitoring and auditing users. So in order to view logged in users, the command is who. So this way you can check what all users have been logged into this particular VM. Currently only Vagrant user is logged in. Now next thing is to check the last login times, and the command is last, and we'll check the John Cena user's last login times. So this is the time when he was last logged in. In order to monitor the user activity, W is the command that can be used. So this is all about monitoring and auditing users. Next and the last topic of this file is scenario based real-time example. So the requirements are as given below. First one is create users alias Bob and Charlie. So the command is user add aponium aponius bin bash alice, then change the name here Bob and Charlie. Alice, Bob, Charlie. So users are created. Second one is add them to group project. So let me quickly add a group add project and add these users to group project. So the command is usermod -a small a capital G. Group name is project. Username is alias Bob and Charlie. Charlie. If I type Alice, I can see Alice is a part of project group. Bob is a part of project group. Charlie is the part of project group. Next thing is to create a directory. So we need to set up a directory, shared directory basically. And the directory name is project ls-ld project. And we need to assign sjd and sticky bit. So in order to assign sjd, the command is chmod g plus s and /project. And we need to restrict access to the directory for the team only. That means the other user should not have access to it. And the command is 770, and to assign sjd 2 is the numeric expression that we use, and we need to provide the directory here. They also want a sticky bit on this particular directory, so chmod plus t and the name of directory, that is project. If you don't want sticky bit, if you want to remove sticky bit, minus t is used. So plus t to assign sticky bit, to remove sticky bit minus t. So we have given all the permissions. We have created shared directory named /project, and we have assigned stid. So these are the two equivalent command that can be used. G plus s can also be used, or numeric expression 2 along with permission can also be used. With any one of the approach is fine. You can use anyone. You can use any of the approach to assign std. And sticky bit is chmod plus t followed by project id. So here you can see. Now let's check whether we have completed the requirements or not. So here you can see the permissions have been given, but the ownership is still root. So let's change the ownership now, and the ownership should be given to team only, project team only. So project followed by, so ownership should be given to project team only. So ch on project, and we don't have a project named user, so let's give a permission to one of the project team member. So ch on alias followed by project to /project. So here we have assigned ownership permission to alias and the group permission to project team. And here you can see we have set the SHID as well as sticky bit. Now let's try to validate all these things are completed or not in a proper manner. So let me switch to alias user, and let me switch to project file, Let me quickly create file named alias file. Check whether the file is created properly. Yes, alias file is created with the username alias and the project, the group as project. So yes, chat is working fine. Next one is Bob. So let me switch to Bob user and let me go to project directory and create Bob file. Let's check the permissions. So here permissions are 644 and the file is created with ownership Bob as owner and project as a group. Now let me try to remove the alias file being a Bob user, and it says operation not permitted. That means sticky bit is also working fine. If I try to edit the alias file, let's check whether I can edit the file of alias or not. So I'm able to edit the file of alias and I can see the container as well. That means the RW read write is working fine for the project group. Since Bob is the member of project group, he can able to edit all the files inside slash project directory. And with this, we are pretty much done with this particular session. We have completed all the requirements for this particular example as well. And with this example, that's all for the today's video on user and group management in Linux. We hope this guide helped you understand how to manage users, assign groups, and configure permissions effectively. If you found this video helpful, don't forget to like, share, and subscribe to our channel for more such tutorials. Have any questions or want us to cover any specific topic? Drop your thoughts in the comment section below. We would love to hear from you. Thanks for watching and see you in next one.